Welcome to Scale series by Dr. Kamal Asif. In today's video, we will talk about Vernier scale. So Vernier scale consists of two parts, a primary scale and a vernier. The primary scale is a plane scale fully divided into minor divisions. The vernier is also a scale used along the main scale to read the smallest unit, which is the fraction of the second unit on the main scale. The least count is the smallest distance that can be measured accurately by the vernier scale and is the difference between a main scale division and a vernier scale division. We have two types of verniers. One is forward or direct vernier. The second one is backward or retrograde vernier. When the markings on the vernier are in the opposite direction to that of the main scale divisions and n plus 1 main scale divisions are divided into n vernier scale divisions, then it is called as backward or retrograde vernier. When the markings on the vernier are in the same direction to that of the main scale division and n main scale divisions are divided into n plus 1 vernier scale divisions, then it is called as forward or direct vernier. Generally, backward vernier is preferred as compared to forward vernier. To understand the concept of vernier scale, let us take one example. So here is the example. In this one, we have to construct a vernier scale to read meters, decimeters, and centimeters, and long enough to measure up to 4 meters. Take RF of the scale as 1:20 and mark on the scale a distance of 2.28 meters. Solution steps. So first we need to find the least count. Now here the smallest unit to be measured is centimeter. Therefore the least count is 1 centimeter, which is equals to 0.01 meter. Then we need to find the length of a scale. This is given as RF multiplied by maximum distance to be measured. Now the maximum distance to be measured is 4 meters. So therefore RF, which is 1/20 multiplied by 4 meters, and convert this meter into centimeters, so multiply it with 100. So we get 20 centimeter. Therefore the length of a scale is 20 centimeter. Then this is our main scale. So the main scale is going to be of 20 centimeter length. Now complete this length with a rectangle. The height of this rectangle is 0.5 centimeter, and then divide this main scale into 4 equal parts, each representing 1 meter. Then divide this 1 meter again into 10 equal parts, each representing 1 decimeter. Now to construct the vernier and to read centimeters, we take 11 divisions of the main scale and then divide it into 10 equal parts on the vernier scale by geometrical construction. So one vernier scale division will be equal to 1.1 decimeter or 11 centimeter. Then we mark these points as 0, 11, 22, 33, 44, 55 and so on till 110 towards the left from 0 on the vernier scale. Once it is done, then we name the units of the main divisions as meters, then subdivisions as decimeters and vernier divisions as centimeters. Then we need to calculate the distance of 2.28 meter, which is 8 times multiplied by vernier scale divisions plus 14 times multiplied by main scale division. So this gives us 0.88 plus 1.4 meter as the division in main scale and the vernier scale. Now to draw the vernier scale, these are the steps that we are going to follow. So first we need to draw a line which is 20 centimeter long, which was the length of our scale, and then complete it as rectangle with a height of 0.5 centimeter and length 20 centimeter. So this is our scale. Now we divide this into 4 equal parts. So for this one, we draw one line, and then on this line we take 4 arcs of same radius. So this is 1, 2, 3 and 4. So these are 4 arcs, and from this one we join the last 4 arc, the last point of the scale. Then from other points draw lines parallel to this one. This divides our scale into 4 equal parts. So this is giving us our 0, then 1, 2, 3 meters on this side, and then 1 meter on this side. Once it is done, then we need to divide this first one and in fact all the one into 10 more equal parts. So first dividing the first one from 0 to 1 on the left side. So here for this one we take this line, draw 10 arcs of equal radius on this line. So here is our 10 arcs. We join the last one with 0, and then from other points draw lines parallel to the first one. Once it is done, for these points we draw lines from the upper part to coincide with these points. So here is the division of this part. Now because we have to divide other parts also into same number of parts, so we can transfer these points with our compass on these divisions. So we have these divisions on this part, and we have transferred this with our compass. So these parts are also divided into 10 equal parts. Now once it is done, then we need to add one extra division in the main scale. So here is our one extra division taken on the main scale, and then we are going to divide these 11 divisions into 10 equal divisions of Vernier scale. So this means that we have n plus 1 main scale divisions being divided into n Vernier scale divisions. So n was 10, n plus 1 makes it 11. So we are dividing 11 main scale divisions into 10 Vernier scale divisions. So dividing the Vernier scale, we have this line, then taking 10 arcs of equal radius on this line, we have these arcs. From the last one, we join 0 and then draw lines parallel to it. So here we have it, the Vernier scale divided into 10 equal parts. For these points, we draw lines coinciding with the divided points. So here we have, now the first one is giving us 11, then 22, 33, 44, 55, likewise 66, 77, 88, 99, and 110. Now we have to mark our 2.28 meter distance on this scale. So this is the marking on the main scale and the Vernier scale, and this distance is giving us 2.28 meters. Now as per divisions, we have this one as meter, then further divisions as decimeter, and the divisions on the Vernier scale as centimeter. This was the least count, RF, and length of a scale, and this was a backward or retrograde Vernier scale, where one main scale division was equals to 0.1 meter and one Vernier scale division is equals to 0.11 meter.